So what was chapter 8 about? Yes, very good stuff. More specifically, what stuff? Yes, via what? The two words I'm looking for. What do we do? All of that. There we go. Hypothesis testing. Specifically for one parameter. In this case, we're going to do it for two. Now it advances. So we're going to be looking at two parameters. In this case, we'll be looking at two different means and two different proportions.
This is chapter 9.
Yes. Then, on to the fun part. When defining the null and the alternative hypothesis, we mentioned how we compare two parameters in our hypothesis test instead of one, because we're dealing with two population parameters instead of one. So your null should use both of them. Blah, 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 blah. Okay. When testing two means or two proportions, we use the same steps as before. So one, state the null and the alternative. It says make sure to define your population. So that just means which group corresponds to what. And you'll see what that means here in a second. Step 2, state your decision rule. It's the same thing as what we did last section or last chapter. 3, calculate the test statistic and p-value if it's necessary. So if we do a z-test, I'll have you calculate the p-value. If we do a t-test, you won't. And part 4, make a decision and relate it back to the problem. So that's just saying whether you reject or fail to reject and interpret it in the context of the problem. And it says our calculations slightly change here to accommodate for the fact that we're dealing with two parameters in this case, or two populations. Then 9.1, just like how it was about for a z-test for mu, now it'll be a z-test for the difference between two means. Then, just as before, when we have a z-test, when the population standard deviations are known. So z-test, if we know, sigma 1, so that's the population standard deviation for the first group, and sigma 2, the population standard deviation for the second group. So that should come as no surprise. Then some assumptions that must be made. I don't know if you're tested on these on the homework or not. Both samples are random. We just mentioned the first thing you need to know, sigma 1 and sigma 2. The populations are normally distributed, or each of the sample sizes is greater than or equal to 30. And then the last one, the samples must be independent of each other. You may need to know that last one. It may come up somewhere. I can't remember if it does or not. That's why I'm saying that. Then page 2 is another summary table. We're not going to fill it in. I already did it for you. There are pictures that go with it for the graphs, but look at chapter 8. It's already there. I probably need to publish chapter 8. Where is that? Here, modules. There. Oh, if you haven't noticed, there's already a practice exam up. And review topics. If you look on the review topics, it actually tells you which problems and examples you should look at. So I would kind of look over those, may help. I hate the stupid thing in this room. Why does it do that? Then we're not going to worry about filling in that table since it's already filled in. Then what does the test statistic look like? I guess we need to say this, test stat. What are you laughing at? Test stat. So it's going to be a z-test statistic Last chapter, we were dealing with one parameter. So we had the, well, I haven't even defined it yet. We'll just give it to you first. X1 bar minus X2 bar minus mu1 minus mu2 divided by a standard deviation of that, which is this square root of sigma 1 squared over n1 plus sigma 2 squared over n2. I guess I should have mentioned this already earlier. The null hypothesis for something like this will be the two group means are equal. What's another way you can rewrite that? Subtract mu2 over to the left. Mu1 minus mu2 is 0. Then how does this equation simplify? If mu1 minus mu2 is 0 under the null hypothesis, that means that is 0. So you're just left with x1 bar minus x2 bar divided by sigma 1 squared over n1 plus sigma 2 squared over n2, all under a square root. So then this is the standard error. And this we could call the point estimate. Then using a confidence interval, what is another way to express that if you're doing a two-tailed test? Be the point estimate, x1 bar minus x2 bar plus or minus what kind of critical value? Since you know sigma 1 and sigma 2, it'll be a critical z times the corresponding standard error. Sigma 1 squared over n1 plus sigma 2 squared. And that's the confidence interval formula. Whenever it asks you to do this on your homework, be very careful whether it gives you sigma 1 or sigma 1 squared. Sometimes it'll say the population standard deviations for each group are, say, 12 for group 1 and 13 for group 2. Then when I plug them in here, what will I have to do to each of those values? Since they're standard deviations and we'll need the variance, you square them both. So be very careful on your homework whether it gives you the variance or the standard deviation. It's usually indicated in the problem. Everyone okay with that? And let's look at an example. There's only one example in here. What in the world? It says a study using 2 random samples of 35 people each found the average amount of time for those in age group of 26 to 35 spent 39.6 hours per week on leisure activities. And those in the age group of 46 to 55 spent 35.4 hours. Assume the population for the standard assume that the population standard deviation for those in the first age group is 6.3 and those in the second is 5.8. At alpha is 0.05, can it be concluded there is a significant difference in the average time each group spends on leisure activities? Does it sound a little bit harder? Then, part 1. I guess I'll start it over here. Identify the null and the alternative. So the null, when you're dealing with a purport or a test for the difference between two means, the null hypothesis is always mu1 equals mu2. Or another way you could write it is mu1 minus mu2 is equal to 0. Whenever we go to the proportion test, that will change, and all it will be is P1 minus P2. It's the only difference. Then, what is the alternative? The last line, can it be concluded there is a significant difference in the average times? It doesn't indicate whether one group will have a higher time than the other. So what is the alternative? Yeah, they're not equal. So mu1 is not equal mu2, or another way you could write that is mu1 minus mu2 is not equal to 0. This next part is just like what we did in chapter 8. Find the critical values and state your decision rule. So it's a two-tailed test with alpha is 0.05. So what critical value will it be? You should probably memorize this one. Yeah, 1.96. So 0.05 two tails corresponds to a 95% confidence level, right? So if you look back in chapter 7 at our critical values, that actually is 1.96. So part 2. Then stating it in this way, reject the null hypothesis. Since it's a two-tailed test, you can write it this way. If the absolute value of your test statistic you compute is greater than the positive critical value. What was the other way you could write this? So you could either say reject null hypothesis if your z-test statistic you compute is less than the negative critical value or greater than the positive critical value. That's just an easier way to say it. If something like this was on your homework, it would say find the critical values, and you would have to put 1.96 and minus 1.96 with a comma in between. Now part 3, compute the test statistic and the corresponding p-value. So using this giant formula that I'm just erasing now. And we'll have to. So something that is usually helpful is if you make a little list. So you have x1 bar. In this case, we're dealing with sigma 1 squared and n1 x2 bar sigma 2 squared and so if you make a little list and then list the corresponding mean for each of the groups. Then for the first group, what is the sample mean? Yeah, 39.6. What is sigma 1 squared? Yeah, something like that. 6.3 squared, whatever that is. And it's squared because I gave you the standard deviation and you need the variance. N1 is what? Yeah, the sample size, 35. What is X2 bar? Yeah, 35.4. What is sigma 2 squared? Yeah, 5.8 squared. And again, N2 is still the same as in 135. Then computing the test statistic Z test is equal to X1 bar 39.6 minus X2 bar 35.4 divided by the square root of 6.3 squared over 35 plus 5.8 squared over 35. Someone tell me the test statistic you get. Yep, 2.90. Then it says find the p-value. So you have the distribution of your z-scores, and you have a p-value, not a p-value, a test statistic value of 2.90. Then you want the area to the right of the positive test statistic and the area to the left of the negative test statistic. That's just how we define the p-value for a two-tailed test. Then what's the easiest way to find that? So the table will already give you the left-hand area, so just take 2 times this left-hand area here. Then the p-value is equal to 2 times the probability of z being less than or equal to negative 2.90. What is that probability of z being less than or equal to 2.90? Someone besides Randall. No. Well, the p-value is close to that. P-value is 0.0038. The probability of z being less than or equal to negative 2.90, you just look up that probability in the table, and it's 0.0019. So when you take 2 times that, it's 0.0038. Then, based on that, what is your decision? Yeah, reject the null hypothesis and conclude there is enough evidence to say there is a significant difference in the average time each group spends on leisure activities. Come on. There it goes. Is everyone okay with that interpretation? Putting it in the context of the problem. Are there any questions over that one? So how would this have changed if it was a, for instance, right tail test? What would change in the problem? What parts? Yeah, so the critical value would change. The alternative hypothesis would change. So it'd be mu1 is greater than mu2. You just said the critical value will change. So instead of being 1.96, it would be 1.65. The test statistic would still stay the same. The p-value would be what? Since it's just one tailed, it'll be half of the original p-value, so it'd be 0.0019. And you would still get the same decision. Does that make sense? What I said there. Then section 9.2. We turn it back around. What is another way you could have came to that decision without doing this part? So that thing used the p-value, right, and compared it to alpha. What is another way you could have done it? Compare this test statistic you got here to the critical values. If it fell within these two, right here, fell within the middle, that means you failed to reject. If it fell outside, so if it was less than this one or greater than this one, you would reject the null hypothesis. And obviously, 2.90 is greater than 1.96. So you get the same decision either way. Then, so that was the z-test. Next, there'll be a t-test. How do you think the formula will change? Yeah, that's it. Then, oh, no, to do that. So it says if they're unknown, so we only know S1 and S2, you will run a t-test, and then the assumptions are right there. Those samples are random, the populations are normally distributed, or the sample size of each of them is greater than 30. And the third one, again, the samples must be independent of each other. Then it says, note, we are still assuming our populations are independent. We will discuss what happens when our populations are dependent in the next section. So that's actually the section we'll probably skip, 9.3. Then there are two different options that we will discuss. So the first one says, assuming whether the two population standard deviations are equal. So that means the first one is, oh gosh, oops. Assuming sigma 1 squared is equal to sigma 2 squared. Then the other one, assuming they're not equal. Then this first option. So it says, although the population variances are unknown, they may come a time that we can assume that they are equal. Whenever we do that, we're going to call it a pooled t-test. In this case, the test statistic gets complicated, so we're not going to do it in this class. So if we're not going to focus on the first one, we'll obviously do the second one. So assuming they're not equal. Then that table thing is still the same as what it was in chapter 8. All the pictures are still the same. The only thing that changes is the test statistic formula. So like someone mentioned earlier, the t-test will be found by x1 bar minus x2 bar minus mu1 minus mu2 divided by, instead of sigma, we will have s for each of them. So s1 squared over n1 plus s2 squared over n2. Then again, how can this formula be simplified? Yeah, mu1 or mu1 and mu2 are the same under the null hypothesis. So that is equal to 0. Then you can also create the confidence interval, and how would you do that? Mimicking the same idea we had last section. This is the point estimate, and this is the standard error. And since you don't know S1 and S2, or you don't know sigma 1 and sigma 2, you have to use a critical t statistic. So it'd be x1 bar minus x2 bar plus or minus a critical t value times the corresponding standard error, s1 squared over n1 plus s2 squared over n2. That's the confidence interval. Okay, so depending on how much time we have left when I finish next time with 9.2, we may actually do 9.3, but I'll make it a bonus thing whenever I upload like an exercise and do it for bonus. Is that fair enough? Since it's not on your homework, but we may have time to do it. So I'll do that. Okay, I guess I'll mention this thing before we leave, and then we'll pull up here next time. So note the degrees of formula changes here. So the degrees of freedom is equal to S1 squared over N1 plus S2 squared over N2 divided by S1 squared over N1, that quantity squared, divided by N1 minus 1 plus S2 squared over N2 squared divided by N2 minus 1. What's up? We're not using that one. I just mentioned it here. Yeah, that's why I mentioned it here. Okay, this formula, just know what it is. It's referred to as Satterthwaite. Satterthwaite. Satterthwaite's approximation. That's what it's called. It's an approximation for the degrees of formula, degrees of freedom, not formula.
How soon will today's lecture? Do you have time to finish this?
Right after class.
Thank you.
We are not gonna use that.
I'm so lost this morning. I'm gonna rewatch everything.
Then how will we use the degrees of freedom? Or find it? So your textbook uses an easier way of doing it. So the degrees of freedom you will use for the test. Degrees of freedom for t-test is the smaller value between in 1 minus 1 and in 2 minus 1. Is that a little bit easier than the formula up top? Yeah, I know. That always scares people. So, and also, this is why we don't do it on the calculator. If you put it in the calculator, it will calculate this degrees of freedom. So we're not using that. All right. Since I said I'll let y'all leave 10 minutes early because I'm not feeling too hot, we'll go ahead and leave. We'll pick up there next time.